Now here at Embedded World this year, every second stand seems to be tackling the topic of machine learning, and not in the cloud, but right down in tiny, low-power microcontrollers. We're talking to Edge Impulse to find out more about their ecosystem, how it all works together, the support they provide to engineers developing machine learning, and their partnership on a new product from Renesas that can achieve visual image detection at 150 frames per second. So hi Jan, it's great to see you here at the Renesas stand representing Edge Impulse. Perhaps you'd just give us a quick introduction to your role in the organization and what Edge Impulse does.
Sure, I am Jan, co-founder and CTO at Edge Impulse. And we're the leading development platform for machine learning on edge devices. We have an amazing platform where people can go and use data to get insight in sensor data. With 85,000 projects right now on Edge Impulse, 300 more are being created every day by an absolutely amazing community of 40,000 developers.
Now the machine learning, artificial intelligence, there's a lot of focus on that at the minute. We see a lot of that here at the Embedded Show. Can you explain a little bit about the Edge Impulse approach to building machine learning applications?
Yeah, so machine learning is, in all fairness, just a different way of writing software. Right? Traditionally, you have a control loop and you have sensor data coming in, and you as a programmer just write rules. If sensor A is X, then do Y. So with machine learning, we've kind of flipped it on its head. We say that for some signals, like audio for example, it's just too difficult to write a control loop. If I want to know if glass is breaking, and I just need to look at 16,000 samples per second and analyze that by hand, it's just not doable. So with machine learning, we flip it around. Rather than say, here's the data, you write the control loop, and then you check the outputs, you say, well, you give the data and the desired outputs, and you let the computer figure out the control loop. But that does require tons of data and quality data. So what we do with Edge Impulse is we'll help you first gather that data. So lots of examples of glass breaking, lots of examples of not glass breaking, right? The counter example. We'll then help you build an ML pipeline, so that typically consists of signal processing. I'm an embedded engineer, like many of your viewers. I like signal processing, it's deterministic. And then we apply some machine learning, sometimes deep learning, sometimes classical machine learning, to then understand the difference between glass breaking, not glass breaking. And finally, when you deploy that, it's just math again. It's in essence no different than writing that control up yourself, but with rules that you probably couldn't figure out yourself. So then you deploy that, it's just source code, you compile it into your application, and now you have machine learning running there.
Now obviously to create those models we need a lot of data, we need to analyze it very carefully. Is that something that I can do on my PC or laptop, or is there a cloud solution to do that analysis and build the ML model?
So within Edge Impulse you do it on your PC or laptop, but in the cloud. So we have a visual editor, sort of like an IDE, specifically tuned for these types of data problems. So it guides you towards whatever. You get a Renesas part, you plug it into your computer, it even shows like directly in your browser, so you can collect data, talk to it, wave it around, or do anything. So that happens in the cloud. All the compute, so the training of the models, generating features, that happens in the cloud. But then after you're done and you deploy, it's source code, and it's complete. So nothing depends on us, there's no connection required on the device, just plain nice C++ source code you can compile in.
Now talking to some of the other exhibitors here at Embedded World, they're talking about having 60, 70 billion microcontrollers in embedded applications.
Yeah.
Which embedded environments, which markets are addressing machine learning earliest, and which ones are sort of lagging behind?
Yeah, it's cool. So just ARM alone, I think ARM's partner shipped 30 billion MCUs in the last year. Like wow. That is just, and that is with a supply chain crisis. So truly insane numbers. So stuff where we see really good pickup early on is in consumer health. So, quantified self. How good am I sleeping? Is my glucose monitoring well? See a really good pickup in smart factory. So is something on a production line normal or abnormal, right? Is a glass broken or is a glass not broken? Just visual inspection, this kind of stuff, really nice pickup. Human-computer interfaces, so being able to have a small model in your headset where you can talk to, really great. One thing that we figured was going to have lots of pickup, but it's kind of lagging, is predictive maintenance. It's this great case of I want to know if my machine is broken, or there's this guy that works in the factory for 30 years, and when he puts his hand on the machine, he knows if it's about to break, and we're going to replicate that. That took a lot longer, actually, than we anticipated, which is kind of funny.
So obviously a lot of continuous development going on the Edge Impulse platform. What are the current features that have been released to the market recently?
Yeah, so the demo that we have on the other side of the booth is FOMO, faster objects, more objects. And FOMO brings object detection to microcontrollers, or really fast object detection to MPU and AI accelerators. So when you think about computer vision, there's kind of two types of models that people deploy in embedded vision case. There's either image classification, I take a photo here, do I see Stuart, yes or no? Or object detection, not just do I see Stuart, but where in the frame is he and how many of them are in that. And image classification is really cheap, we can run it on an MCU. Object detection, super expensive. Like you need a GPU almost to do this in real time. So FOMO brings both of these things together. So object detection in kind of an MCU footprint. The second thing they're working a lot on is to help people build data sets. It's kind of the hardest problem when building a machine learning algorithm. It's like, how do you get good, high quality, properly labeled data? So we've released data sources and the data explorer, and those help you kind of build this active learning loop where you put a device in the field. If it's unsure about something, okay, send it back to us. We'll compare it to all the other data in your data set, maybe use a larger model that doesn't fit in your device to analyze it, and you just label those news clusters. Like, oh, there's a new fault state because all of this data is certainly in another place. Then you retrain and you push it back to the device, and now it's smarter. And that keeps going on, so, yeah.
Now, obviously your focus has been on the embedded side of things. We see lots of microcontrollers with various different types of cores. But here at the show, we've also seen the introduction of neural processing units, of accelerators for AI. Are you able to support those?
Yeah, so we work super closely with our silicon partners. We have an amazing silicon ecosystem around it. So very often we even launch together with the release of these NPUs. So when Scilabs was releasing their new XG24 3 months ago, Edge Impulse support from day one. Renesas is releasing their new accelerator on Cortex-A. We're there from day one. So, and we do this really deeply. So for the user, it's almost transparent. You build your model in the same way. We'll give you suggestions on what will fit and what won't fit on the target that you're actually working with. We'll suggest models that fit your footprint. And we'll take advantage of anything we can do under the hood. And we do this on Cortex-M, Cortex-A, ESP32, RISC-V, special MPU, special stuff that is in silicon, and literally anything in between.
This is a dynamic market. There's so much going on. It's moved so quickly in the last few years. What do you think we're going to see in just maybe 5 years' time?
Man, it's so hard to imagine, right? But okay, so as a try, so why is every IoT device that people build a temperature sensor that sends stuff to the cloud? It's because I can go to DigiKey and buy a temperature sensor, and there's nothing that can go wrong. Well, sort of. I once burned my hand because I put it in my breadboard the wrong way. But my feeling is that 5 years may be a bit too early, but maybe in 10 years, I should be able to just go and buy a smart sensor that just uses machine learning internally to sense the real world in a way that kind of IoT promised me to.
Okay.
I want a people counter. I want a, do I hear glass breaking sensor, just something really small, like whatever, $1, similar to what we now have around thermistors or Hall effect sensors.
All of those modules for Arduino and Raspberry Pi you can buy today.
Yeah, but then properly integrated and real use cases. People promised me IoT is going to bring real insight in the world, and what do we have? Well, lots of smart temperature sensors, right? I want real insight, and machine learning is the only way that can actually offer that, because it's the only method that can analyze audio and vision and really complex sensor streams in real time on these edge devices. So I think it's an amazing time to be had in this space.
Well, thanks ever so much for those fascinating insights into the world of machine learning. We see a great success, I think, in front of us with Edge Impulse, and we wish you all the best at the rest of the show.
Wonderful. Thank you, Stoker.
So hi Amir, great to see you here at Embedded World 2022 again. Could you just give us a bit of background about your position at Edge Impulse and what you've been doing?
Excellent. So Amir Sherman, I'm the Global Business Development Semiconductor in Edge Impulse. And after 20 years career in the distribution and semiconductor market, selling chips and SOMs and solutions, I moved to the software, machine learning type of industry because I see that the next evolution of embedded and IoT is machine learning in the edge. We are here at Embedded World. We see a lot of noise on machine learning in the edge, and this is exactly what we are doing, driving and supporting embedded engineers to really democratize the way and simplify the way they can add machine learning into the edge.
Now we're here at the Renesas stand looking at some of the demonstrations that work on their microcontrollers, but it's not just Renesas that you support, is it?
Yes, exactly. So yeah, we are here in the Renesas booth and we just announced supporting both on Renesas microcontrollers and microprocessors. But Edge Impulse is supporting any type of processor. So you can run from a simple Cortex M0 Plus to M4, M7, utilizing the DSP inside the chips. You can support the latest generation Cortex from ARM, the M55 with the Ethos U55 that is coming to it. But it's not only from ARM, it's running on RISC-V application, can go from a Cortex-A application, GPU application, from the smallest microcontrollers up to the high-end GPU. And this is how Edge Impulse is supporting the engineers. Renesas is a good example because we signed both on the microcontroller side, supporting the RA5 family, running a Cortex M33 with machine learning application for predictive maintenance for voice application, and we even support them with the the Z family, running on Cortex-A machines with the DRP AI, that is a special accelerator supporting video application, running our model called FOMO that you will hear more in the future, and many type of applications.
Now machine learning and artificial intelligence are quite complex applications to build. You need lots of data, and not every semiconductor vendor is sort of ready to be able to support their customers. What's the value for a semiconductor vendor when they pair up with Edge Impulse?
So this is a wonderful question. In the end, semiconductor industries know how to sell and to build great chips. And software is more complex. So to win the market, you need a lot of partners. Partners to support real-time operation system and graphic drivers and networking drivers and a lot of things that they need to complete their solution. The next big thing is machine learning to the edge. And what Edge Impulse is able to do is support them to simplify the way that engineers will be able to develop. If you look in the industry, many companies have an army of machine learning software engineers, Python engineers, companies that have engineers understanding TensorFlow, and they know what to do. And they can utilize our platform. On the other hand, many companies, they know how to develop code for embedded development. And they are stuck because they need to add machine learning. So what we are doing, we are able to support them end-to-end, from data-driven, data forwarding, upload data, to do the training, up to the deployment. In the end, they are getting a code that they can implement and put in on their machine, and it's easy. They don't need to be scientists to understand the technology. They have tools to make it more fast in the market.
Now, a lot of industry and market spaces tend to move from components to systems on modules or SOMs. Do you see that happening here in the edge space with machine learning?
Excellent question. So in the past, people thought that machine learning on the edge will run only on microprocessors. So you have big system on models running big processor, GPUs like NVIDIA and the Cortex-A1. Now, the market evolves, and you see now there is a new system on module trend. And the module are taking the microcontroller, the AI accelerator, connected with connectivity, like Bluetooth, like Wi-Fi, like NB-IoT LTE Cat-M1, and sensors. So you have a small boards with the sensors, with the microcontroller or processors, and the wireless connectivity. And we are showing a great example of something that we developed with a partner. So microcontrollers or neural processing unit with the sensors, with the connectivity, showcasing what we call a TinyML SOM for voice activation, keyword spotting. And this solution can be moved even to the Industry 4.0 application, like as an example, predictive maintenance. You put it in close to a motor or gas pipes, and they can listen using acoustics, vibration, and this is where the market wants. Now, it's not that complex to develop that SOM, but if you have that TinyML model, you can go to a proof of concept very fast. And we are working with the partners to support that.
Now, machine learning and AI algorithms tend to rely on the cloud in order to do some of their work, but then there's some stuff that has to function in the device, like a wake word with Alexa, for example. Do you see that expanding the support for more words in an edge application?
No, this is wonderful. In the past, we were so excited about Alexa. Hi Alexa or hi Siri, and then there was a wake word, something happened. But then the second sentence, every data is going to the cloud. Hi Alexa, what is the time? The what is the time going to the cloud. What we see now is that you can do a lot of keyword spotting, a lot of things that is on the edge. So for example, we work with a security company, and this security company said, we would like to have a special access control, working, no internet connection. It needs to be really out of internet. Now, how you will be able to support face recognition, biometric fingerprint, and voice command without internet? 5 years ago, it was not being possible. Today, you can do that. So for example, we connected, and in this case, it was working between us. One company was working on the battery application. So you have a semiconductor company waiting to listening to the wake word. And then you are coming, you're saying, hi, it's Amir Sherman. So this is the wake word. This wake up another system that is the Linux system. You have time for booting, and then the first thing you see on the HMI, can you put your fingerprint? So you put your fingerprint, and then you have the access. And then you're moving to the third thing, face recognition. You're in front of the camera, and then it's saying face recognition. Again, it's not one to many. It cannot do it one for 1,000 people. But 10, 20, you can do it on the edge. And then you're getting that access control. Things that was not impossible 5 years ago, now it's possible. And this is cooperation between semiconductor companies and the platform from Edge Impulse.
Well, thanks very much for that deep insight into what's going on at Edge Impulse and the future of AI and machine learning on the edge and in embedded systems. That's
excellent.
Fantastic.
Thank you very much. Enjoy the show. Thank you.
Thank you. So, hi Arun, it's great to see you here.
Likewise.
Representing Edge Impulse at the Renesas stand. Just give us a quick review of your background and role within the organization.
Yeah, so my name is Arun Rajasekaran. So I am head of solutions within the sales marketing organization, the business side of things within Edge Impulse. So I've been with them for 7 months now, feels like 7 years. They are a startup. So they are in the machine learning space, as you would know, and solutions is nothing but what our customers effectively need Edge Impulse for. So that's what the term solutions is about, use cases and how machine learning is used in their actual products.
Now, what are those customers finding most challenging when they're tackling these machine learning projects?
Well, that's an interesting question. So machine learning in general has been a popular topic, but most of it has been in the cloud. And what is happening aggressively, and you can notice it in this Embedded World conferences, the value proposition is coming very much closer towards the endpoint, the embedded world. So what Edge Impulse does is help bring that machine learning use cases to tiny devices, from devices that are running on very small, Renesas chips, which was completely impossible 2-3 years back. So it unlocks value that didn't exist before. Most of these devices in the endpoint, they were doing very rudimentary functionalities that are done, possible using embedded firmware, very logical stuff, and machine learning gives that ability to run intelligent capabilities, which allows devices to bring more value to their end users.
So what's the tool chain look like from Edge Impulse in order to support them and help them through that process?
Yeah, and Edge Impulse is a tool chain meant for enterprises to build machine learning models that much more easily, and it doesn't replace certain kind of skill set, but it accelerates the development of it. It's a very intuitive, graphically simple interface that allows engineers with very limited background in machine learning to get their job done, and that has been one of the biggest success factors behind why Edge Impulse is where it is today.
Obviously you've been in contact with lots of customers and seen a lot of projects coming through the Edge Impulse ecosystem. What have been some of those sort of standout, surprising applications where you've really thought, wow, that's a great use case?
Oh yeah, no, that's a great point. That's actually one of my focal entities, since we had been listening to a lot of customers, prospective customers, as to what use cases they have in mind. So we have identified very select verticals that are going to be the early adopters of bringing machine learning to the endpoint. So what we have done within Edge Impulse is identify these few verticals and figure out what use cases matter to them, and we had been building internal capabilities to build reference designs, show off content around these so that companies that need to productize this have an easier time and an early time to market. So the key verticals in this space are companies that are working on hearable devices, wearable devices, smart spaces, think of smart building related industries, Industry 4.0, which is in a huge transformation of a very old legacy industry that is adding digital transformation capabilities to understand what's happening, with their machines and whatnot. Logistics, so think of asset tracking, asset management like use cases within logistics. And then there's the public sector. So all the four industries I talked about are private sectors. Public sector is becoming very aware. Various governments are thinking about, for defense purposes or non-defense purposes, how they can use machine learning, and we are seeing a lot of traction amongst these 5 specific industry verticals.
Now, I think there's this perception out there still that machine learning requires cloud performance, powerful servers, but obviously you've brought that down to a very low level. But I mean, what sort of microcontrollers and SoCs are supported?
Yeah, no, that's a great point. That has been the concern among the technical community, thinking that all machine learning related stuff has to be happening in Amazon cloud or Google cloud or whatnot. The cloud still has its immense value. So I see most of these as pendulum swinging. Intelligence is not going to be completely living in either extreme. It's going to be depending on use case to use case. So one of the big transformation reasons why intelligence is gravitating towards the endpoint is because of what the silicon industry is doing. Companies like Renesas and whole slew of others, they have been making the end embedded silicon affordable with the right amount of compute and even more sophisticated compute happening inside. So this allows machine learning workloads to happen with lot of ease compared to what was not possible before. That said, there's also another revolution happening in some ways. Companies like EdgeImpulse allow you to use the tiniest of silicon to run not too complicated workloads, but workloads that are still not possible 3-4 years back, but today feasible to make devices intelligent enough. Think of ARM M0, this is the tiniest possible compute engine you can think of. Machine learning capabilities running on such cores is something that was deemed to be impossible, but an EdgeImpulse-like platform allows you to do that.
Now, data is key to machine learning. You can't get around that point. What advice do you have for development teams starting with machine learning, and what should they do to tackle the data collection issue?
It's a huge point. With machine learning, data is key, like you mentioned, and garbage in, garbage out. So the EdgeImpulse platform actually pays a lot of attention to what we call data engineering, right? So it visualizes the data for you, helps you clean up the data, because the quality of the data determines how your model is going to take shape. And even within that, we have done a lot of innovation to figure out how we can build efficient models with reasonably decent amount of data. The traditional knowledge thinking is that machine learning needs gobs and gobs of data. That is not true in all cases. In some cases that is, but not in all cases. So we have done innovation in machine learning capabilities to have reasonable amount of data, but quality data. Quality more than quantity in the right cases has helped make the developers have an easy time building models. For example, keyword spotting, it's a huge human-machine interface capability. Think of Alexa, OK, Google-like situations. Industry used to think that you need tens and hundreds and thousands of data samples to build the right model. But there's so much innovation that's been happening in academia, which you have leveraged on, to build what's called few-shot keyword spotting, which is just with hundreds of data samples, you can have equivalent performing high accuracy models, which are very resilient, noise immune. So those are the type of innovation. Quality is important, and the machine learning platform like EdgeImpulse allows you to have the right amount of data to build your models.
Well, thanks very much for those insights. It's been really interesting to understand how that package will work together for machine learning, and we look forward to seeing how EdgeImpulse progresses in the coming years.
Yeah, no, it's exciting. It's early times, and that's one reason probably machine learning is going to take some time, because there are a lot of people who will wait and see to see how this is progressing. There are early adopters who are having really an amazing time using the EdgeImpulse platform to productize their machine learning use cases. So with the ecosystem that we are building with silicon vendors, which you heard Jan and Amir talk about it, and with silicon IP vendors, there are folks who supply silicon intellectual property to the silicon vendors, the universities, the developers. So Edge Impulse is building a community from all angles in terms of engineering and silicon and whatnot. That is a feedback loop that we see that's going to really make enterprises really sit up and listen to what's happening in the embedded space and bring in machine learning workloads. So the roadmap ahead is innovation in machine learning, innovation in data engineering, and innovation with the integration of your ecosystem partners, which makes the life of the end customers, the enterprise customers, so easy to develop what they need to develop.
Super, thanks very much, Arun, for your time.
Oh, you're welcome. Amazing, nice having you, thank you.